Welcome to another Spotlight video where we walk you through a spotlight figure from your textbook. This video walks you through the contraction cycle spotlight found in Chapter 7. After watching this video, you should be able to describe the contraction cycle of muscle. This is important for understanding how skeletal muscle works. For instance, have you ever wondered why you can't run at your top speed indefinitely? Or why rigor mortis occurs in a dead body? The contraction cycle begins when the nervous system activates the release of calcium ions from the sarcoplasmic reticulum. The calcium binds to troponin, a protein in the troponin-tropomyosin complex. This binding changes the shape of the complex by exposing the active sites on the actin molecules of the thin filament. Now that these sites are available, myosin heads of the thick filaments bind to them, forming crossbridges. Energy is stored in the myosin heads in the form of ADP and phosphate, and this energy is utilized to pivot the myosin heads towards the M line, the center of the sarcomere. As this power stroke occurs, the myosin heads release ADP and phosphate. A new ATP molecule is then required to disconnect each myosin head from the active site, detaching the crossbridge. This new ATP molecule is quickly split into ADP and phosphate, re-energizing the myosin head for another cycle. As long as calcium ions and ATP are both present, the contraction cycle continues and can occur many times each second. In summary, the contraction cycle is a coordinated series of steps that begins with calcium ions binding to troponin and exposing the active sites of the actin filament. The binding of myosin to actin forms a crossbridge, followed by a power stroke and crossbridge detachment. The myosin head is reactivated by splitting ATP into ADP and phosphate. So what? Why is it important to understand the contraction cycle? Well, this can help us understand exercise physiology. When we exercise, why can't our muscles contract indefinitely? One reason is that if a muscle cannot supply enough ATP to meet demand, the muscle will fatigue. For example, you cannot sprint forever because your mitochondria can't continue producing ATP rapidly enough. Dehydration can also cause muscle fatigue because the associated loss of calcium ions interferes with the contraction cycle. And why does a body undergo rigor mortis, or stiffness after death? As calcium ions leak from the sarcoplasmic reticulum of a recently deceased person, they bind with the troponin-tropomyosin complex, allowing crossbridge formation. However, there is no new ATP being formed to allow crossbridge detachment, so muscles throughout the body become locked and stiff. Rigor mortis generally appears about 4 hours after death and can be used to determine time of death and whether the body has been moved after death. A dead body at a suspected murder scene, positioned as if sitting in a chair, but found on its back with both limbs up in the air, is clearly suspicious. As you can see, an understanding of the contraction cycle is important for both exercise physiologists and criminal investigators.